All right. Hey, gang. I hope everyone's doing well. What I want to do over the next couple minutes is kind of walk you through 2.3, 2.4, and then 2.3b, the last hard part of 2.3b, and then 2.4. Actually, what I'm going to do for this page with the story problems on it, I want to see what you guys can do on for those problems. So I'm going to give you a chance to kind of work through that. If there are questions, let's talk about those in the days that come. Next time we meet. But I want to quickly get into some of the problems that we're going to be looking at today, which would deal with variables on both sides of the equation. So when I look at the very first one, the warm-up problem up here, let me go ahead and get this webcam off. Okay, here's what I see. Oh, let me make that little. There you go. Okay, here's what it says. The two figures, a regular hexagon and a regular pentagon, have the same perimeter. What is the length of a side of the pentagon? So as I look at this, what a regular polygon is in general is that all sides are congruent. And what congruent means is that they are equal. And each of these little tick marks right here tells me that each of these sides are the same measure, same length. And then all the angles are congruent as well. So these little arcs that are inside these angles also tell me that each angle has the same measure, that they are also congruent. Over here in the pentagon, you've got 5 sides. They're all the same length. Notice that they are marked with 2 congruency marks. They are not the same length as this side over here in the pentagon or in the hexagon. Okay, with 2 congruency marks, that tells me that these 2 lengths are different lengths. Okay. And also I have got 2 congruency marks here in each of these, which tells me all the angles here are congruent, but they are not congruent to each of the angles over here. They don't have the same measure, okay? So if the perimeters are the exact same, I'm going to set up the equation like this. There are 6 sides over here with a length of 3x plus 5. So I'm going to set it up like this, okay? And over here there's 5 sides with length 4x minus 1. Okay, so if we go ahead and solve for x, if we distribute and distribute, we get this. Okay, don't forget to multiply this term, both of these terms by this term right here. Okay, same thing over here, multiply both of these terms by this term right here. Now from here, when you have variables on both sides, you want to get the variables to one side. So I'm going to go ahead and take this positive 18 to the other side of the equation. I want to get this x away from this side to this side. In order to do that, I have to get rid of him. So that gives me 30 on the left-hand side. Make sure you're bringing your equation, your equal sign straight down. 20 minus 18 is 2. Okay, now to get the x by itself, I have to do something with this guy. Well, to get this guy over here, he's a negative right now, so I'm going to make him a positive, opposite of what he currently is. And so this is 2x is equal to 35. Okay, now if I go ahead and continue to divide by 2 to solve for x, my x value is 17.5. Okay. Now, to make sure I've done this correctly, I can actually plug this back in and figure out the perimeters of each shape, the hexagon and the pentagon. So for over here, if I take 3 times 17.5 and add in 5, let's go ahead and take a look and see what that would look like. 3 times 17.5, add in 5. Oh. Let's go 2. Okay, and we're going to add in 5. I forgot to put the 5 there. Okay, that would be 57.5 for one side length. So the perimeter would actually be 6 times that. So 345 units, whatever that would be. For the other one, if we do the same thing, 4x minus 1, 4 times 17.5 minus 1, okay. Okay, is going to be 69 for a length. But now you notice that these are not the same. Okay, 69 is not the same as 57.5, but it wasn't that their side lengths were the same. We already know that they were different based on the way they were marked. The perimeters have to be the same. So if I take 69 times 5, oh yeah, there you go, 345. All right, so anyways, I just want to make sure that you understand how to go ahead and solve for variables when they're on opposite sides. For example, if we continue to work our way down through this expression right here, this equation, we have 2x is equal to x plus 5. I'm not big on using the algebra tiles right now, okay, but later on this year when we start multiplying polynomials, we'll get into that, and so you'll see it then. So if I want to get this x over here, I'm going to subtract him. X is equal to 5. Now, to double check myself, when I plug him in, what's 5 plus 5? Well, that's 10. What's 2 times 5? That's 10. We're good to go. Oh, goodness. Sorry about that. I thought I had it in the right spot. Okay, so hopefully that makes sense to you, what I wanted you to do there. Okay, you can check it to make sure. One like number 18 can be or 1b can be a little bit tricky here. If I want to get the a's to one side, I can either take from both sides and say, hey, this is a positive 5, so I'm going to subtract 5a. Over here, this is a negative 7a, so you could add 7a. I like to try and keep my variable positive. It's just a personal preference. So I'm going to add 7a to both sides. Those guys are gone. There's no more a's on the right-hand side. So this would be 12a plus 2 is equal to 6. Well, if I want to get the a by itself, I'm going to have to do the opposite of the 2. So I'm going to do minus 2. 12a is equal to 4. And then to get a by itself, that's 12 times a. So I'm going to divide by 12. And a is going to equal 1/3. Okay, 4/12, which is 1/3. Okay, now that darn fraction. Let me show you how you can put this into your calculator here. So this is, move that up a bit. This is 5 times 1/3 plus 2. So 5 parentheses 1/3, 1 divided by 3 plus 2. Okay, so we get 3 2/3 or 3.6 repeating. Okay. The other one is going to be 6 minus 7 times 1/3, 1 divided by 3. And there we go. We get the exact same thing, 3 2/3. Okay, so get in the habit of checking your work, plugging things back in, making sure everything is correct. Okay. You know, we can continue to expand and you know, down here we want to make sure we distribute. Distribute. So it just can get bigger and bigger as the problems go along. All right, so make sure that you are following your rules here. So I'm going to leave those for you guys to go ahead and fill out. The last one, find the value of x so that the figures have the same, oh, get it up there, have the same perimeter. Okay. Kind of like the, well, do I want to show this one? I'm not going to show this one. I'm going to see what you guys can do. I want you to impress me, okay? So I'm just going to have you guys work through those other problems. If you have questions, come back and talk to me. But otherwise, I look forward to seeing what you could do. We'll talk to you later. Bye.